Hi, this is Mrs. Slater, and today we're going to multiply polynomials with radicals, and you're going to see a lot of the same things we've done in our past just show up here. For example, this is just the distributive property. So we're going to take the radical and distribute it. Square root can only be multiplied with square roots, so it's going to look like this. 5 times square root of 2 and square root of 3. 3 square root of 2 and square root of 5. The only thing we can put together is the square roots. So it would be 5 radical 6 and 3 radical 14. Neither one of those have common factors. So there's no way that we can break that down any more than what it is already. So that's going to be our final answer. The next ones are all binomials times binomials. And yes, that is foiling. So again, blast from the past. We've got the first terms, which is square root of a, square root of b, and then I'm going to put the 3 in the front. The outside, which is negative 4, square root of a, square root of 3. The insides would be positive 6. And here I'm trying to do as many details as possible. So 2 times 3 times 3 times, square root of 3 times square root of b. And then the last, so here's our first, outside, inside, and then the last term is going to be 2 times the negative 4 times the square root of 3 times the square root of 3. Okay, so that's a lot of writing down. So I want you to start using mental math. For example, like if I was to start this over again and think of FOIL, you don't have to erase what you just did. But now it's just a simple way to take the first and the last. Sorry about that. First terms, 3, and the radicals are all going to go together. Outside, negative 4, radicals can go together. Inside, plus 6. The non-radicals can go together and the radicals can go together. And finally, the last terms, negative 8. And square root of 9. Okay, now looking through this, is there anything else that can simplify? These are all different, so we can't add or subtract any of them, but this one right here is a perfect square. So our final answer for this one would be 3 square root of AB, 4 minus 4 square root of 3A, 6 square root of 3B, and finally 8 times 3 is going to be 24. So that would be your final answer. All of that would be the finale. Okay, the next one is squared. So there are 2 of them, a binomial times another binomial of the same exact quantity. First, outside, inside, last. First, again, start using your mental math. 2 times 2 is 4. Square root of 5 and square root of 5 multiplies together to give you 25. Outside, negative 2y on the outside of the radical, square root of 5 on the inside. Okay, now both the insides are going to be a negative 2y, square root of 5, and last is plus y times y is y squared. Okay, then again, look to see what we can simplify. Same. So those are like radicals. We can put those together like rads. So that's negative 4y square root of 5 plus y squared cannot be simplified, but we do know that this is a perfect square. So 4 times 5 is 20. And that is where we're going to stop because nothing else simplifies. Always check and look to see if something else is going to simplify. And then the last one, this is also FOIL. First is 8 times 8. Outside is plus 40, square root of x. Inside is negative 40 square root of x. And last is negative 25 square root of x squared. Okay, in order to simplify this, 64, there's nothing in common with anything else. Look at the middle 2. One's positive, one's negative. What does that mean? They cancel out. So that original was difference of 2 squares right here. Okay, it cancels, leaving us with negative 25 square root of x squared. And we know that from the past here that that's just x. So it'd be 64 minus 25x. And I know there's lots of rules to remember, but anytime you square root a number, this is going to have the absolute value. Even index, odd exponent. So you're going to need an absolute value sign. Okay, so the title of the next one is How do we rationalize the denominator? Okay, this is going to be helpful for our future lessons. We need to have absolutely no radical in the denominator. And you can see that each one of these has a radical there. So we're rationalizing the denominator. And what you're going to need to know is we want to multiply whatever the bottom radical is. We're going to multiply the top and the bottom. So I'll show you what happens when you go ahead and multiply by the radical on the bottom. The top becomes radical 6. The bottom becomes radical 9, which the denominator, if you multiply it by itself, it will always be a perfect square. So you have square root of 6 over 3. Okay, so let's do the same thing on the second problem. Square root of 3b, square root of 3b, multiply it across. We have 12ab on the top, and the bottom is the square root of 9b squared. So square root of 12ab all over 3b, absolute value around the b. And what else can we simplify? Always look for that next step. If you notice 12 right here, that is a number that has a perfect square into it. So I'm going to continue down here. Square root of 4 is a number that can be broken down. 3ab cannot, and we're still over 3 absolute value of b. So our final answer would be 2 square root of 3ab all over 3 absolute value of b. Okay, again, lots of rules to know in this chapter, so you have to practice these problems. Erase them or whatever and start over again, but you have to practice. The next one, you may want to multiply by 3 over radical 3, but that is not a radical, so I'm not really concerned with getting rid of it or multiplying by it. Okay, so if it's not a radical, we can just multiply by the radical only. And if we're multiplying, the reason why this works is because we're multiplying everything by 1. This equals a value of 1, so we're not changing the value of the problem. We're just changing the way it looks. Okay, so we have square root of 15 on the top, 3 and square root of 9 on the bottom. So square root of 15 over 3 times 3, which is 9, and nothing else is going to simplify. Okay, and then on the next one, we can always simplify what's inside first. Then we can multiply by what's going to make it go away. So this one's a little tricky because before we've only just multiplied it once. So I'm going to separate it. Let's continue down here. Cube root of 1 is just 1. So that we can go ahead and simplify. And then we have the cube root of 2 on the bottom. Okay, now if I multiply by the cube root of 2 on the top and the cube root of 2 on the bottom, you can stop writing for a minute and just listen. You'd have the cube root of 4. But is that a number that can be broken down? No, we need a perfect cube. So if it's cube, we're going to need 3 of the same radical in order for it to break down, because now we're going to get the cube root of 8, which does break down into 2. So this is one of those that you should erase and then try to do it on your own. And then on the top we get 3 cube root of 4, which doesn't break down, but that's okay because it's on the top. We are looking to rationalize the denominator, so the denominator cannot have a radical in it. Okay, similarly on this one, we're going to need 2 of them, cube root of 7, in order for it to break down. Again, we're multiplying these both equal 1, so we're just multiplying something by 1, and anything times 1 is itself. So when you multiply them, you end up with cube root of 3 times 7 times 7. Ooh, what is that? And then all over 3 cube root of a big number, which ends up being 7 at the end. You may have noticed that pattern. And then when you multiply 3 and 7 together, you get 147. And there are no perfect cubes that go into it. So that's going to be your final answer. All right, and then the next one, instead of 2 or 3, now we have an index of 4. So we're going to need to multiply by 4 of them. So it'll take a while to write all those in there. There's so many. I won't go any more than that on tests or quizzes, so don't be alarmed by that. Multiplying the top all together, you're going to need your calculator for that to get 250. And then all over 5 for the final answer. Okay, so let's go ahead and go to conjugates. Conjugates are a way to rationalize the denominator when you have a plus or minus sign there. So the conjugate is going to be 1 plus radical 2. This one would be square root of 2 minus square root of 3. Notice what's happening here. Square root of 3 minus 1. And then the last one's conjugate is plus 3. Okay? All of these, a conjugate is the exact same thing with the sign switched. Okay, now let's use that on the example problems. If I want to rationalize the denominator using conjugates, I'm going to multiply the top by 1 plus square root of 2 and 1 plus square root of 2. Again, this equals that value. What I just put in green equals 1, so I'm not changing the value of the problem. So we have 5 and then 1 plus radical 2. And if I FOIL, and this is what's nice about a conjugate. Look what happens. This is 1. Outside is positive square root of 2. Inside is negative square root of 2. And last is negative square root of 4. If you simplify it, that goes away. This is 1 minus square root of 4 is 2. So you get negative 1 in the denominator. That will always happen when you're multiplying by a conjugate. So let's go ahead and finish this up. We have 5. When you distribute, 5 plus 5 radical 2 all over negative 1. And if you divide by negative 1, you get negative 5 minus 5 square roots of 2. All right, again, push pause if you need to. Write that down. Redo some of the problems just to practice. Okay, I'm going to do one more with you, and then you can finish the next one for class tomorrow. This right here would be multiplied by square root of 2 minus square root of 5. That is called the conjugate. This, again, conjugates are used to rationalize the denominator. Anything times 1 is itself, so I don't have to do much there. And then the bottom, little FOIL, square root of 2 and square root of 2 is 2. Outsides and insides are going to cancel every time on a conjugate. And then the last term is going to be a negative square root of 25, which is 5. So I'm going to bring that over, give that a negative 3. And then that I'm going to leave as my final answer. Can't do anything else with that. So I want you to have this one done for class, not wait until we get to class. And that's all I have for you today.